You know that used oil from your car? Ever really think about where it goes? Well, most of it is just considered waste, and it's a huge pollutant. But what if I told you we could turn that dirty, black liquid right back into a pristine, valuable product? Today, we're diving into some pretty incredible industrial alchemy to see the engineering behind an oil re-refinery plant.
All right, so here's our game plan. First, we're going to kick things off with the basics, what this is and why it's so important. Then, we'll look at what it actually takes to build one of these massive facilities. After that, the really cool part. We'll follow a single drop of oil on its wild journey, peek under the hood at the core technology, and we'll wrap up by looking at how these plants are designed to protect the planet.
So, first things first, what are we really talking about here? And more importantly, what's the big problem this incredible technology is trying to solve?
At its absolute core, re-refining is all about transformation. It's this super sophisticated process that takes something we'd normally just toss out, right? Used lubricating oil, just full of gunk and contaminants, and it meticulously cleans it, strips away all those impurities to get back to the good stuff, the pure base oil. That's the oil before they mix in all the performance additives. And that base oil can then be used all over again.
And look, this isn't just some neat science trick. It's a huge deal for the environment. If you dispose of used oil improperly, it can wreak havoc on our soil and water. So re-refining isn't just recycling, it's really upcycling on an industrial scale. It closes the loop, creating a circular economy for a vital resource. It's basically turning a huge environmental headache into a super valuable asset.
Okay, so you've decided to build one of these. What's next? I mean, how do you even start to put together one of these giant transformation factories? It's not like building with Legos, that's for sure. It's a massive, massive undertaking.
Well, it all starts from the ground up, and I mean that literally. Crews come in, clear the site, lay down these huge foundations. Then the real fun begins. The core machinery gets installed, piece by giant piece. First, the pretreatment units, to get the water out. Then you see these towering distillation columns go up. After that, the high-tech treatment systems that give the final product that polish. And finally, you have to weave it all together with the plant's life support. All the critical safety and utility systems for things like firefighting and pollution control.
All right, this is where it gets really cool. Let's follow a single, lonely drop of used oil as it gets pulled into the plant and starts this incredible journey from gunk back to gold.
Right away, we hit a huge engineering problem. You've got this thick, sludgy oil, and you need to separate it. The obvious thought is just boil it, right? But if you try to do that at normal pressure, you'll just burn it. It decomposes into this useless black gunk called char. So what do? How do you separate the good stuff without completely destroying it?
The brilliant engineering solution is you cheat. You change the rules of physics. You lower the pressure. That's the magic of vacuum distillation. Think about it like this. If you try to boil water on top of Mount Everest, it boils at a way lower temperature, right? Because the air pressure is so low. It's the exact same principle here. You create a vacuum, and suddenly the oil can vaporize without getting hot enough to burn.
And the result of all this clever engineering? It's just wildly efficient. I'm talking up to 90% recovery. Modern re-refineries can take that used oil and turn 90% of it back into high-quality, reusable base oil. I mean, to put that into perspective, the older methods, they were lucky to get even 2/3 of that, with a ton more ending up as low-grade fuel or just waste. This isn't just an improvement, it's a complete game changer.
Okay, so let's zoom in a bit. Let's get right inside the technology and look at the actual hardware that makes all this magic happen, the real heart of the machine.
You gotta think of the whole plant as a living thing. The massive vacuum pumps and columns, those are the lungs, creating that special low-pressure atmosphere. The heat exchangers and furnaces, that's the circulatory system, meticulously managing the temperature. And then you have the advanced filtration systems, they're like the kidneys, purifying everything and making sure the final product is pristine.
So for that final, super important polishing step, there are really two ways to go. You've got the old school way, acid and clay treatment. It works, it's pretty effective for basic cleaning, and yeah, it's cheaper. But then you've got the modern approach, hydrogenation. Now this is way more advanced. It costs more, for sure, but it's much more eco-friendly. It actually uses hydrogen gas under high pressure to chemically scrub out the last tiny impurities. We're talking about polishing the oil molecule by molecule. The result? You get this incredibly high-quality, crystal-clear base oil that's good enough for the most demanding engines.
Okay, but let's be real. When you're building a plant that's designed to handle a major pollutant, you have a huge responsibility, right? So how do engineers make sure the solution doesn't just create a whole new set of problems? It really all comes down to two things: containment and control. The whole site is built like a giant concrete bathtub, basically, to make sure that if there's ever a spill, nothing gets into the ground or the water. They have special systems just to capture what are called volatile organic compounds, or VOCs, to keep them from getting into the air. And any water they use gets treated right there on site before it's ever released. It's a completely closed-loop philosophy, from start to finish.
And get this is my favorite part. Even the tiny bit of gunk that's left over at the very end, this thick, heavy sludge, it doesn't just get dumped in a landfill. Nope, it gets processed and turned into fuel bricks. So it gets a whole new life. Absolutely nothing is wasted.
You know, what we're really looking at here is a perfect example of something called industrial ecology. It's this idea of designing our industrial systems to work like natural ones, where the waste from one thing becomes the food or the feedstock for something else. There's no such thing as waste in nature, and that's the goal here too.
So, that really brings us to the big takeaway. This whole process just proves that with some really clever engineering, and honestly just a shift in how we think, something we see as useless, waste, can be turned back into a valuable resource. And that leaves me with a question for you. If we can do this with dirty oil, what other waste out there are we just completely overlooking?